is a plus 2. Okay, so we can write ith element address is a plus I minus 1, because third element address a plus 2, second element address a plus 1, so 1 less than the that position. So ith position ith element is address is a plus I minus 1. Okay, it is the address of the ith element. Okay, so that means here we add 1, then 2, then I minus 1. What is this? A is the base address 100. A is the base address 100. 100 plus 1, 101 is the second. 100 plus 2, 102 is the third element address. So similarly, suppose I value is 5. So A plus 5 minus 1. So what is A value? A value is 100. 100 plus 5, 105 minus 1, 104. You can see 104 is the fifth element address. 1, 2, 3, 4, 5. Fifth element address is 104. Okay. So when we store data sequentially, and to store one data, we required only 1 byte. We required only 1 byte. What is 1 byte? 1 byte equals to how many bit? 1 byte equals to how many bit?
8.
8 bit. Okay, 8 bit. To store one data, we required only 1 byte. Okay, suppose this is it is better to store. This is not actually feasible. This is actually wrong. If I store, suppose, any character X, Y, A, B, C, okay, N. To store one character, we required only 1 byte of memory. Okay, to store one character, we required only 1 byte of memory. So this is suppose character array. Okay, now this is the base address. What is the base address? Base address means first element address of the array. Okay, first element address of the array is called the base address. It's called base address 100. So next address is this 1 byte long. So 100 plus 1, 101. What is the next address? 100 plus 2, 102. What is the next address? 102 plus 1, 103. Okay. So A is called base address or first element address. Second element address A plus I. Third element address A plus 2. Ith element address A plus I minus 1. Okay. Do you have any question?
No.
No. Now, suppose we represent one integer type array. Suppose integer type array name is A1. Okay. Here, so 23, 38, 4, 9. Okay. So this is 1, 2, 3, 4, 5. Now, suppose the base address is 100. Okay, and to store one integer value, we required. Okay, to store one integer value, we required, suppose, 2 byte of memory space. Okay, so 2 byte of memory space. So what is the address of the next location?
100.
An integer type array. To store one integer, we require 2 byte of space, and starting address is 100. What is the next location address?
102.
102. Then 104.
Sir,
106. Yes.
sir, but to store any integer, we need 4 byte.
2 byte or 4 byte, it depends on the compiler. Okay.
Okay, sir.
If you are using 32-bit compiler, then it is 4 byte. If you use 16-bit compiler, To store one integer data, it's required 2 byte. If you use 32-bit compiler, then to store one integer data into our primary memory or RAM, it's required 4 byte. Okay. So 4 byte, if it is 4 byte, then first starting address is 100, next address is 104, then 108, 112, 116. Okay. Hello.
Yes, sir.
Yes, sir. Okay. Now, so what is the base address? Base address is with 100. Means first element address. Okay. To store 20, you can see this is suppose our RAM. Okay. So to store 20, we required 2 byte. This 2 byte, this 2. Okay, first one is 100, second one address is 101. So into our RAM, each memory location is 1 byte. Into our RAM, each memory location is 1 byte. Okay, to store one value 20, if you want to store 20 here, we require 2 byte. So first address is 100, second address is 101, then address is 102, then address is 103. Okay, if you want to store 3, this 2 byte is required, 102 and 103. But if you want to know what is the address of first location, it is 100. What is the address of second location? It is 102. Okay, it always provides the first address. Okay, suppose when you store 20 here, what is the big first address? 100. It is 100. Now, if you want to know what is the address of A2, what is the address of A2? Which is 102. But actually, if you want to store 3, it's required 2 byte. So it requires 2 location, 102 and 103. Now, if you want to store 38, it's required 104, 104 and 105. Suppose this is 104 and this is 105. Okay, so these 2 memory location is required to store 138. Is it clear to everyone?
Yes, sir.
Sir, once more, sir, please, sir.
Okay. What is the address of the first location? 100. Okay. 20. If you want to store 20, we require 2 byte, because if you want to store one integer value, we require 2 byte. Okay. That is called word size. Okay. What is word? Word is a technical term into programming or computer term, that how many byte is required to store one element. Word is nothing but how many byte is required to store one element. Maybe that element is any data type, integer type, character type, float type, double type, string type, structure type, okay, any type. To store one element into our primary memory RAM, how many bytes is required? That is called word. Okay, so here we store integer type of data. So this is an integer array. If you want to store 20, how many byte is required? 2 byte. So 100 and 101. This is our RAM structure. Into our primary memory or RAM, each location has its own address, and these addresses are sequential. That means first address 100, then 101, 102, 103. This is 104, 105, 106, 107, 108, 109, 110, 111, like this. Okay. So to store one element, suppose 20, we required 100 and 101, 2 byte. But if you want to know what is the address of the one location, means A1, what is the address of A1, it is showing into our programming. If you write %u, comma, ampersand A1. Okay, you can see the output is 100. It is showing actually the first address, not to both the address, only the first address. And similarly, if you want to store 3, you require 2 byte. So 102 and 103, these 2 byte, 102 and 103, these two locations occupied by this value 3. If you want to know what is the address of A2, it is represent the first address of that particular block. So A2 is 102. Now it is clear to everyone?
Yes, yes.
Okay. So now address of A1 is 100, A2 is 102. Okay, what is the address of A3? A3 had address is 104. So we can write a common formula that address of AI equals to base address B plus W into I minus 1. Okay, B plus W into I minus 1. Suppose we want to know what is the address of A2. Okay, what is the address of A2? Second location address. So what is the B value? B value is 100. Okay, B value is 100. Means second index, a second element. A2 means second element. What is the address of second element? Okay, 100 plus, what is the W? 2 byte.
2 byte.
I value is 2 minus 1. 2 minus 1, 1. 1 into 2, 2. Plus 102. You can see second element address is 102. Second index element. Okay, second index. Suppose you want to know what is the address of A5. Okay, so B plus W into I minus 1. So B value is 100 plus 2 into 5 minus 1. So 108. So fifth index element address is 108. Okay?
Yes.
So here you can see what is the address of fifth element? B plus, suppose you want to know what is the address of fifth element. B fifth element address B plus W into I minus 1. So B value is 100. What is the W value here? What is the value of W?
8.
Not 8. To store one integer, to one character data, how many bytes is required?
1 byte.
Correct.
1 byte. 1. I value 5 minus 1. 5 minus 1, 4. 4 into 1, 4. 104. You can see fifth index element address is 104. Okay? So to know this type of questions may come that the base address is given. Okay, what are the requirement? If we need to know the base address and the word size. Okay, then we can calculate the address of any location in our 1D array. We can calculate the address of any location into our 1D array. Please write down this equation.
So written.
Okay. Now, suppose this is array B. Okay. Suppose this is some value is there. So 0, 1, 2, 3, and last index is 9. Okay. There is a lower bound. We can represent lower bound by L. What is lower bound? Lower bound is the starting index of an array. Okay, starting index of an array is called lower bound, and another is called upper bound. What is upper bound? Last index of the array is called upper bound. So, suppose this array index starts from 0, so lower bound is 0. If array index previously here, what is the lower bound? 1, because array index starts from 1 here. So here array index starts from 0, lower bound is 0. Upper bound, what is the last index? Last index is 9. Okay. So if you want to know index of A3, okay, you can write L plus I minus 1, means third element index. What is the third element index? Suppose here we store 6, 8, 11, 9, 50, 22, 30. What is the third element index? Index of A3 means third element. So this is first element, this is second element, this is third element. Okay, third element index is 2. Let's check 0 plus 3 minus 1, which is 2. Okay. Now, if you want to know what is the size of array A, how do you know the size of the array? Using L and U, which formula we can write? We want to know the size of array, suppose, sorry, it is B. This is B. Okay. Array name is B here. What is the size of array B? We know the lower bound, we know the upper bound. How do you
Yes,
know
sir.
the size of the array B?
Upper minus lower.
L minus U. U minus
L
L.
minus U. Okay. Here.
Sir,
Here
L plus L plus P.
L equals to 1, U equals to 5. So 5 minus 1, 4. But here 1, 2, 3, 4, 5. Total 5 elements. So L minus U is wrong.
L minus U plus 1.
L minus U or U minus L?
U minus L plus 1.
So U minus L.
Yes. L is smaller than U, na? So U minus L plus 1. This is, using this we can find out the size of the array. Okay. Suppose L value is 20, U value is 40. How many elements is present? 40 minus
21.
20 plus 1, 21. Okay. So from 20, 21, 22, 23, last index is 40. The starting index of the array is 20, last index of the array is 40. So what is the size of the array? U minus L plus 1. Okay.
Yes, sir.
Okay. Now, suppose base address of the array is 1020. Okay. Question 1. Lower limit or lower bound, okay, same thing, 1300. To store one element, that means word size to store one element in an array, it is 2 byte. Okay. Find out the address, okay, of A1700. Find out the address of 1700. Find out.
Sir, 4418.
What
Yes,
is
sir.
lower limit?
4418. Sir,
No.
4418.
3418. The 3498.
What is lower limit?
Sir, 1300.
Here you can see what is the lower bound. What is the lower bound or lower limit? You can say same name, lower bound or lower limit. Okay, that means the starting index. Okay.
Starting, yes,
Index.
yes,
So your starting index is 1300. So base address is 1020.
5718.
1020 is nothing but the address of 1300. Okay, my array is like this. 1300. Suppose the array name is A and address is 1020. Okay. We want to find out the address of 1700 location. So suppose this location is 1700. I want to find out what is the address of this index, 1700 index. This is the lower limit, means starting index 1300 index, and 1020 base address means address of the first location 1020. And to store 1 byte, it's required 2 byte, means first address is 1300. What is the next address? This location address 1302. Next address 1304. Okay, this location.
Sir,
Sorry.
address.
Sorry,
Sir,
that's
address of
1122.
1122.
This is the index. Oh, sorry. This is 1022. This is 1024. Index is 1300, address 1020. Index is 1301, address is 1022. Index is 1302, address is 1024. Similarly, when the index is 1700, what is the address?
So 4418. 4416.
What is the formula?
So B plus W into I minus 1.
I minus 1 or L? Okay. Sorry, this is not 1. This is I minus L. Okay. Here starting index is 1. That's why 1. It is I minus L. Please rectify this. B plus W into I minus L. According to this question, it is correct. But generally, B plus W into I minus L. Okay. B plus W into I minus L.
So 1028.
No.
Oh, 1820.
Yes, 1820. What is the base address?
1020.
W value, I value,
1700.
1700.
L value.
300.
Okay. So if you calculate, so 1020 plus this is 400. 400 into 2. 800. So 1820. Okay. The formula is AI equals to AI, okay, equals to B plus W into I minus L. Okay, this is the formula. Using this formula, we can find out the address of any 1D array. We need to know base address, word size, and the starting index. Starting index. L nothing but the starting index. We can say it is called lower bound or lower limit. Lower bound, or we can say it is called lower bound. Okay, or limit, lower limit. Okay, the B nothing but the base address. What is the base address? Means starting index element address or starting index address. This is called base address. Okay, that means elect index address is called base address, and W is word size. Is it clear to everyone?
Yes, sir.
Okay. So this type of questions may come that base address is given, the array suppose starting index is given, word size is given, find out the address of any particular index. Using this formula, you can find out the address of any particular index given 1D array. Now, we will discuss 2D array. Okay, 2D array. Suppose this is one array. Okay, how can we represent any 2D array? Using matrix. Okay, we can represent any 2D array in pen and paper using matrix. So this is how many rows? How many rows? 0th row, 1 row, 2 row, 3 row. How many rows? Total number of rows? 4.
4.
And how many columns? 0, 1,
Three.
2. Total number of column? 3. Okay, total number of column is 3. So we can represent any array. Suppose this is the array name is A, array 4th rows. You know the first box represent number of rows, total number of rows, and second represent total number of column number of rows, total number of rows, and total number of column represented by this. So how many elements present into an array? Number of rows into number of columns. So 12 elements present. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if it is an integer array, and to store one integer value, we need 4 bytes. So total how many space is required to store this array? So 12 element is present. 12 into 4 equal to 48 byte is required. Okay, to store one integer value, suppose to store only one integer value 11, we need 4 byte data space. To store 12 integer 12 to total 12 integer values, we require 12 into 4, 48 byte of space. Now the question comes, how in pen and paper we can represent any 2D array into a matrix, but how do you store into our primary memory or RAM? How do you store? Okay, how do you store into our primary memory or RAM? Suppose this is our RAM or memory. Memory means actually called primary memory. How do you store? Each location has some address. Okay, suppose this location address is 100, 101, 102, 103, 104, because memory location always continuous. 105, 106, 107, and so on. Okay. Now, how do you store this element? We can store row wise or we can store column wise. So that's why it is two term. One is row major order. Okay, row major order or row major wise, whatever, and another one is column major order. Okay, row major order and column major order. What is row major order? If we store data in array 2D array data into our primary RAM, row wise, first we store first row, then we store second row, okay, then we store third row, then we store fourth row. So then it is called row major order. Means first we store here 11, then 12, then 3, then 8, then 7, 6, 11, 12, 3, 8, 7, 6, then 4, then 19, then 6, then 7, then 20. Okay. So here address is 107, 108, 109, oh sorry, 100, no, sorry, one thing. Eleven, 12, 3, 8. Okay. First address is 100. Next address is, what is the next address? 100.
102.
104.
4 byte, na? Then 108,
8,
112, 116, 120, 124, 128, okay, 132, 136, 140. This is actually not 100. If we, this is this block actually, there is a 4, okay, into primary 4 location, 100, 101, 102, and 103. Okay.
Sir, after 4 you missed 5.
Sorry,
After 4 you have missed 5.
after 4.
Yes, sir. In the second row. In the second row after 4, that's 5, not 19. 7, 6, 4, 5,
Okay. Yes,
19.
sorry. I missed 5. 7, 6, 4, 5, 19, then 6, then 7, then 20. The address here 144. If you store this data row wise, first row, then you store second row, then you store third row, then you store fourth row, this is called row measure order. Okay. Now, if we store data column wise, you can see if we store data column wise. So starting index address is suppose 100, 104. Here starting address was 100. Okay. So 100, 104, 108, 112, 114. No, sorry, 104, 8, 12, 16, 116, 120, 124, 128. 132, 136, 140, 144, and so on. Okay. Now we store data column wise. So first we store 0th column element, then we store 1 column element, then we store next second column element. So first we store 1, 8, 4, 11, 8, 4, 6. Okay. So first we store here 11, 8, 4, then 6. Okay. Then we store 12, 7, 5, 7. 12, 7, 5, 7. Then we store 3, 6, 19, 20. 3, 6, 19, 20. Okay. So please see here, when you store data row wise or column wise, it will fill up sequentially. First 100 location, then 104, then 108, then 112, then 106. You cannot store one data first at 100 and next data at 140. Okay. So when we store any array data, it's stored sequentially. If you store row wise or column wise, it will store sequentially. Okay. So here,
Sir, so can we choose if we want to put it row wise or column wise in the program?
yes,
So can we choose if we want to store the data column wise or row
yes,
wise
yes,
in
you can store the
program?
data. Suppose I represent rows and J represent column. Okay.
Oh,
So
sir,
for-
just exchange. Yes, sir.
just exchange. So now we want to know the address of 7. What is the address of 7? Row wise 140, but column wise 2 as 7 is there. No. Suppose any unit. Suppose 8. What is the address of 8? 112. Okay. But what is the address of 8 here? 104. Okay. So this is column wise. Column measure order. Okay. So if we store data row wise or column wise, this is column measure order. But always data stored sequentially. Haphazardly we cannot store because it is an array. So we know the array element stored sequentially. So that's why first we occupy the 100 memory location, then 104, then 108, then 112, then 116, then 120, 114, 128, and so on. Okay. So row wise means row measure order means we store data row wise, or column measure order means we store data column wise. Suppose we want to find out the address of 19. So address of 19, you can see row measure order is 132, but address of 19 in column measure order is 140. Okay.
Yes, sir.
So in the next class we will discuss that how to find out the address of any particular location of any 2D array in row major order and column major order. Why we need to find it in two defined way? Because here you can see if we store data row major order, address is 132. If we store data in column major order, address is 140. So address is different. In the next class we will discuss, suppose one array is given, base address of the array is given. What is the base address of the array? Row major order 100, a column major order 100.
100.
Order also 100. Base address always same. If you store data row major order row wise or column wise, base address always same. If we know the base address, how many byte is required to store one data, okay, and number of rows and number of columns, so easily we can find out the address of any particular location. Suppose we want to find out the address of 2-1 means second row first column, second row first column, this element address. Okay. If we store this data row wise or column wise, we can find out the address of any array, address of second row first column, that means 5. Okay. So this element address we can find out. Suppose A22, A22. What is A22? A22 is 19. A22 is 19. Now, if we row major order, 19 address is 132. In column major order, 19 address is 140. Okay. In this class we will discuss, we can derive a formula that using this formula we can find out the address of any particular locations, particular element. Okay. A22 nothing but represent one element. A22 means what? Second rows, second columns. Second row, second column. Element 19. So 19 address. If we store 19 row wise, what is the address? 132. If we store 19 column wise, what is the address? 140. Okay. And we also try to solve some problem. Any doubt? Any question? Yes or no?
Yes, sir.
So this type of question is important for your mid-sem exam. Okay, especially 2D array. 1D array is very easy, but 2D array. Am I going fast or slow?
Sir, okay, pace.
Okay, sir. Okay, attendance please. Please response. Roll number 101.
Present, sir.
1026. Yes, sir. 1058.
Present, sir.
141. 541.
Present, sir.
1134.
Present, sir.
119.
Present, sir.
1206. 119. 5119. 5119 absent. 1206.
Present.
Present.
119.
1206. 51206.
Present, sir.
35.
Yes, sir.
46.
Present, sir.
53.
Present, sir.
68.
Present, sir.
51315.
Present, sir.
48.
Present, sir.
97.
Present, sir.
99.
Present, sir.
51427.
Present, sir.
34.
Present, sir.
67.
Present, sir.
5148.
Present, sir.
51539.
Present, sir.
51603.
Present, sir.
65.
Present, sir.
663.
Present, sir.
673. 51673.
Present, sir.
5168.
Present, sir.
51883. 51883. Aryan Kumar. 885.
Present, sir.
1910.
Present, sir.
1939.
Present, sir.
85. 51985. Bisaka Ghosh. 52005.
Present, sir.
5205.
Present, sir.
5207.
Present, sir.
52072.
Present, sir.
52110.
Present, sir.
52129. Obhirup Dotto.
Present, sir.
5213.
Present, sir.
Yes, sir. Present, sir.
Okay. 52187.
Present, sir.
52253. 52253. Jai Pandey. 5227. 5227. 52270. Hello, am I audible?
Yes, sir.
Yes. 5270 absent. 5229.
Present, sir.
52460.
Present, sir.
52516. 52516. Pratyush Rath. 52532.
Present, sir.
52540.
Present, sir.
680.
Present, sir.
700.
Present, sir.
865.
Attending, sir.
932.
Present, sir.
5294. Priyanshu Raj. 5294.
Present, sir. Present, sir.
5318.
Present, sir.
5320.
Present, sir.
53469. 53469. Suraj Shah. Present. Suraj Shah. 5353. Amisha Kumari. 5353.
Present, sir.
Present. 53469. 469 present. Okay. 5479.
Present, sir.
5491.
Present, sir.
5567.
Yes, sir.
5575.
Yes, sir.
5651. 5651. Riya Raj. 5660.
Present, sir.
5678. 5678. Sweta Kumari. 5798.
Present, sir.
5809.
Present, sir.
5811.
Present, sir.
5814.
Present, sir.
15.
Present, sir.
7.
Present, sir.
25.
Present, sir.
22. 53. 58.
Present, sir.
53. 5895.
Present, sir.
5936. 5936. Abdul Khan. 5939. Abhijit Jha. 5957.
Present, sir.
5959.
Present, sir.
5960,
Present, sir.
5992.
Present, sir.
Sir, 2270.
1 second.
Sir, 2253.
1 second. Absents are 51883.
Present, sir.
51985. 52253.
Present, sir.
5227. 5227.